Hello, and welcome to tonight's webinar, How to Start Your Java Project Quickly on AWS. My name is Catalin Dumitras, and I am a Principal Cloud Architect here at Pentalog. Before we start, some admin things. First, can anybody hear me and see me properly? Please use the chat section. Awesome. So, as part of tonight's session, there will be a Q&A session at the end. Please make sure to use the Q&A section here in Zoom. All right. Awesome. So, to set tonight's context, you are a Java expert and you're on a new greenfield project for your company. Unfortunately, the new resources that were supposed to be assigned to you are nowhere in sight. Sprint 1 is coming to an end, and the business stakeholders would like to see what you have done with the new app. Now, how can you solve this? Well, we'll pretend for a second that we haven't seen the title of this presentation, and we're going to go into a bit of a details on why the cloud and why AWS in particular might be a good fit for you. So, why should you use a cloud in any scenario? Well, usually cloud services allow us to deliver more, faster, and to focus on what matters. All right, but what does this mean? Well, cloud services are the new type of software components. They are allowing you to integrate new and feature-rich services to give you more to your application in a shorter time. Basically, they're the new, less open source components to integrate into your application. All right. Now, before we get into more details, I'd like to give you a short overview of tonight's session. After we continue with the why should we use AWS on the cloud, we're going to start, as all developers start, by doing a small local application. We're going to start something with SpringBoot. We're going to see some options there because we have more than one. We have generators and a few other things. We're going to continue to create a test environment in the cloud, of course, using the latest methodologies, and then continue to create a production environment. At the end, this wouldn't be complete without creating a continuous integration and delivery pipeline. Of course, at the end of the session, we'll be doing a demo of the whole thing end-to-end, starting from a Git commit into our IDE and seeing it reach live into production. All right. So I got a bit carried away with what and how the cloud helps us to do. But usually when we talk about the cloud, we talk about two main concepts: the concept of abstraction and automation. Should you really care about how a network-attached storage gateway operates, or how a load balancer does things internally? Is that your main focus? 9 out of 10 things, 9 out of 10 components really that make up your app in the end are commodities, are stuff that you don't really have to build. Let's take a quick example as a car. Most car manufacturers don't make their own parts. They buy components from third parties and then integrate them into their own products, their own cars, where they focus on the things that matter to their customers, the designs, the newest infotainments, so on and so forth. So what cloud technologies allow you to do is to integrate those components into your applications. So let's call them commodities because that's what they are. Stuff like storage, database servers, so on and so forth. and allow you to focus on the stuff that really matters for your clients. Okay, so that's one part of it. The second part is automation. Since you are able to treat your infrastructure more or less as a software component, this opens the door for a lot of automation, which definitely helps a lot in gaining more time for you to be up to date with the newest technologies and to research again, invest time in the stuff that matters to you, and worry less about is your database backed up or not. All right, so what type of services or what type of options do we have when we host our new applications? Because we talked about that context in which we're short on time, very short on time. Let's say we're at the end of sprint 1 and tomorrow we have our demo meeting with our business stakeholders. So usually on an on-premise environment, we'd have to take care of everything. And when I talk about on-premises, that means either a data center or somewhere actually in your office. We would have to manage everything from the connection to the office, to the hardware buying process, to the installation of the operating system. And after everything is said and done, maybe then we can focus on actually deploying our application. In the infrastructure as a service model, which all cloud providers offer, they take away or abstract at least 3 layers, which is the network, the hardware, and the storage. And they allow us to focus at least on the operating system and all the other layers above. Now, this is definitely a major advancement, but we can do better. We have platform as a service where we don't really have to manage either the operating system or the database. Now, there's a new kid on the block, which is called serverless. Now, serverless is very, very cool. We only have to care about our application code. Unfortunately, it does have one main drawback. We have actually to take a much closer look at our application and use new architectures and new paradigms to deliver serverless applications. Now, most of the time, obviously, this works reasonably well. And it provides with great benefits. There are great selling points when it's time to showcase our architecture to your clients, to your stakeholders, because telling them that they only have to pay when a user actually uses the application really helps sell things along. But in our scenario, there is no time for re-architecting your software. You have to do something, and you have to do something now. So the best we can do by using cloud services is to use a platform as a service offering from one of the major players. And then we don't have to re-architect or learn new skills or tools. So it's clear that platform as a service might help us in our quest today. So which offering do we choose? Again, let's pretend you don't know the title of this talk. But if we were to look a bit on Google or one of the major consulting companies like Gartner, we will see that one name does stand out. So for example, AWS has been the leader in the infrastructure as a service quadrant, their magic quadrant, for the least 9 years running continuously. And one thing I really do like is the pace of innovation. This was screenshotted from a recent conference from AWS, which they showcase how many features they release each year. Just in 2018 alone, there are almost 2,000 features. So obviously, as a pace of innovation, that's a very good option. All right. So let's start the practical part. How do we start a cloud project with Java, with Spring Boot? Well, we have 2 main options. Today, every major language has their own generators. React has Create React App. Um, General Node has JavaScript has npm. PHP has Composer. Python has pip. Pretty much everybody has one of these, and associated tools, extenders. So specifically for Java, we have two that stand out: the Spring Initializer and the JHipster. JHipster is a wonderful tool. I just wish they would add the code pipeline when it comes to CI/CD, but it's pretty complete and it's very feature rich. On the right, we even have a nice little screenshot from Spring Initializer. The second group of options is starting from example projects. These are actually very cool because they actually allow us to start with something that's working. Sometimes a lot of the work comes by configuring the most basic things, including database connection. But one option in particular I'd like to focus on today is a community demo done here by Zianwar, probably not pronouncing that right. It's a basic SpringBoot CRUD demo, CRUD standing for Create, Read, Update, Delete. And in the end, it's supposed to look like this if everything is installed properly. So to save time, before this webinar, I downloaded this to my desktop and I opened it in the popular IntelliJ IDEA editor, community version. And let's see if it would work. Let's start it up. All right. Going to our local port 8080, the default for Spring Boot, we can see this nice little CRUD demo showing up here. We have product, but let's also add another one ourselves. Let's add another product called webinar. All right. So this works. If anything goes wrong, it's because I didn't do the configuration in the cloud properly, because it works on the local machine. Awesome, I think. All right. So how do we go about creating a test environment? First, let's talk about the platform as a service offering from AWS. It's called Elastic Beanstalk. And it's quite an interesting offering because it allows us not to work just with Java, but pretty much every major language out there. So we got .NET, PHP, Node.js, Python, Ruby, so on and so forth. And if there isn't a version that is specifically to your fancy, or if your application is a very old enterprise one or a very non-standard one, you can always use Docker, and you can use whatever, basically you can deploy whatever you want that can run on Linux. All right, so there are three major options when it comes to deploying applications on this platform as a service offering called Elastic Beanstalk. You can use the web interface, you can use the CLI, or you could use infrastructure as a code. We're not going to be touching a lot about infrastructure as a code right now, but what we're going to do is going to use the console. This provides the least barrier to entry and a lot of help wizard style. So I guess it makes the most value in the shortest amount of time. All right, so what we are going to do is we're going to create that new Elastic Beanstalk application. We are going to create a new test application server, create a new test database, upload our app, and test it on the new environment. Keep in mind this graphic at the right. We are going to come back to it once the application is configuring, because it does take a while to boot up. All right, so I'm logged into my AWS console in the London region. This is the first page that you see when you go into the services, compute, Elastic Beanstalk. Click on Get Started. And let's call our new application Webinar. We're going to, of course, configure it as a Java application. We're going to want more options because we would like to also add a database. We're going to leave most of the defaults on. And we're going to start creating the app. Second. All right, it's a demo. It never works in the first try. Let's upload a zip file. This won't actually work because we have to add some files, but I want to start the actual provisioning. All right, so it's uploading. And once the process starts, we'll come back to the presentation so we can discuss a few moments about that graphic and what it means, and also explain some of the AWS terminology that we'll be using. There we go. All right, so let's take a small look at the graphic on the right. We start with the AWS cloud. Logically, it's going to be deployed on the AWS cloud. What's a region and what's an availability zone? So a region is a geographical area where AWS has grouped multiple availability zones. And the advantage of a region is that it's completely separated from all other AWS infrastructure, right? So if you hear US 1, so that means US East 1 or EU West 1 that has issues or anything like that, one issue will not affect another region. So there's this concept called limiting blast radius. So that means isolation, segregation of resources. So whatever issue happens is not going to affect other people someplace else. Now, inside regions, we have availability zones, which are distinct resources, so different data centers. One availability zone does not mean one data center. Usually, it's comprised of many more data centers, but they are close enough geographically. They're very proximal to each other that AWS considers their power, their internet to be very, let's say, as a single line, because it's so close, it's pretty much dependent. If one data center has an issue, the chances are the other ones will as well. So when it comes to AZ1 and AZ2, or sorry, AZ A and B in a specific region, they are totally separated, different internet connections, different power lines, pretty much everything. They do share some connectivity in terms of software. Right, so there is the slight possibility that one of the services that are globally inside the region might affect each other. What is EC2? So EC2 stands for Elastic Cloud Compute. It's basically virtual machines. So what Elastic Beanstalk is doing in the background is configuring these EC2 machines for us, so we don't have to. RDS stands for Relationship Database Service. It's not just for MySQL. There's actually quite a few database engines available in RDS. We have Oracle, MySQL, MariaDB, Microsoft SQL Server, and I believe there's another one I'm missing right now. And all of these are fully managed for you. Besides configuring the instance, you will see that you have a ton of options, including automated backups every day, point-in-time restore, high availability, extremely easy to get, and you will actually be seeing this when we create the production environment. We will be able to create a highly available environment, both at the compute level and also at the database level, extremely easy. So let's see if our environment is up. Unfortunately, it's still gonna take a minute. What it has done, it has added a security group, which is basically our firewall. It has created an IP address for us, and it's starting the RDS database. All right, so since we have a few more minutes, I guess we can try and see if there's any questions so far. Actually, no questions, but I do see some people writing on the chat. All right, so, Postgres, thank you very much. Yes, Postgres is also available. So please do use the Q&A section for any questions you might have. One interesting thing while we wait is that Elastic Beanstalk also offers the option to manage or deploy multiple Docker containers at once. So if you're accustomed on your local environment to use something like Docker Compose, it can work wonderfully for you. It can be deployed very easily. However, if you're a Kubernetes fan, this is not the service for you. There's another service specifically for Kubernetes. And one of the benefits I haven't actually discussed so far is that Elastic Beanstalk itself is free. And the AWS only charges you for the raw resources you use when creating this environment. So you would only be paying for the application server or classic EC2 machine and the RDS server, the database server in this case, since we have a non-highly available environment. All of the features in Elastic Beanstalk is free, and its basic purpose is to help you get started quickly on AWS. All right. I'm going to quickly go to Q&A section. Nothing yet. Okay, so while we wait, let's prepare the application for uploading. I mentioned that this is not going to work by itself. Why? Because basically there is no specific information on how to work with Elastic Beanstalk. So I am going to go into my prepared folder here and take the following EB extensions and add it to the project. And let's take a small look on what this means in our IDE. We have one file which basically adds an environment variable that says for Spring that you will have to use two profiles when you create, when you start up the application, the Beanstalk profile and the MySQL one. The MySQL one is because we have a MySQL connection to the database, and we need to load that destination as well. And the server port, of course. Elastic Beanstalk expects Java to be listening on port 5000. And if we take a look at the Beanstalk configuration, which we'll see here in the resources folder, I'm not sure if you can see this very well, so I'm just going to quickly see if I can go to the presenter, the presentation mode in here. And what this basically does is configure Spring to use environment variables in the JDBC connection string. So it will get the host name, the port, the database, the username, and the password. Now, this is very important. It's not just because we don't want to commit credentials in our Git repository, because that would be bad practice. It's also very important because we don't have to think about on what environments will this application end up in. Whatever environment you have configured with Elastic Beanstalk, it will automatically have these environment variables in if you have attached an RDS database. So that means that I don't have to save any type of credentials in here for the test, UAT, staging, performance testing, security testing, production, whatever you want to call it. They all use environment variables, so we never have to store credentials. Also, the small file here is for Hibernate to generate the database file. This is something already existing in the project itself. All right, let's see if we have a working environment. All right, so we have a new database, and the EC2 instance is launching. That means it should be over quite soon. Okay, so once we have these, let's prepare our first deployment on a test environment. So what we actually have to do, we have to take the build jar that's done by Maven, and we bundle it up with these EB extensions. And we do a small zip file. That should be sufficient. All right, so we have a nice new environment set up, and we have a URL for it. It says bad gateway because it's not listening. Our project is not listening on the right port, and even if it would not be able to connect to the database. So let us choose our application build with everything required, and let's deploy it. And this should actually be much faster than what we have been waiting for so far. All right, while this is deploying, I'd like to go over some of the items on the left menu, because these are very, very interesting indeed. So we talk about platform as a service. We have a lot of configurations when it comes to this platform as a service. We can configure the type of instances, so that means how much CPU, memory, disk, because IOPS stands for operations per second, so we can actually deploy hard drives there that are very, very powerful and can support something like a high-performance database of some sort that's not available for managed service. We have a lot of options when it comes to security as well. It automatically configures the necessary firewall rules between the web server and the database, for example, and from us to the web server, because normally you can't access it without opening the required ports. All right, what I would also like to show you is the log feature. So Before I go back to the configuration for the security, because I wanted to mention something, there's a very, very easy way to look at the logs in your instance, right? So all you have to do is request the logs, and it can either show the last 100 lines, right, from everything in your var log folder, or you can actually request the full logs, and it will zip up var log and allow you to download it and view it at your pleasure. But what happens if you actually want to go inside the machine? So by default, you'll see that it's not configured with an SSH key, which is actually a very good option. So a very good standard, because managing SSH key pairs is not easy, and it's also very, very hard to change them, because you have to redeploy them to everybody. You're not sure who has it, who shouldn't have it. It's a mess, really. So what you could use, and I advise you to look into that, is EC2 System Manager Sessions, which basically allows you to log in from the management console in your browser to the instance and basically be in SSH and have a bunch of added security. Because if you remove somebody from the console or they don't have permissions, they can't access your EC2 instances, your virtual machines. And the best part is you can configure logging. So everything people type into SSH, it can be logged to a storage bucket, which is very, very cool indeed. All right, we do have a nice monitoring dashboard, bit of a high CPU utilization at the moment since we're deploying, and some network stuff in here. So let's see, do we have, yes, it has been deployed. Please work. Yes, yes, it does. So our new test environment is here, and I would like to add something here. It's called test. Now let's make it free. Okay. So now we have, let's go back to the slides for 1 second. Now we have an Elastic Beanstalk application in the cloud running our code, right? Our local code. Basically, we have a test environment right now, which is awesome. I mean, it didn't take me long. It took me about 10 minutes, 15 at the most. Let's see how we can create a production environment. Because obviously, if it's that easy, we might as well do it now and impress our stakeholders. So we want a production environment. We could clone it very easily. We could do it manually, but why should we do that? But what would make it production? Just the name of it? How about if we add something cool like high availability or auto scaling? High availability means that in case of availability zone going down, again, not just a data center, but a group of data centers close together going down, it means that your clients would never notice that a whole data center is missing, right? So one data center goes away, your EC2 virtual machine is gone, it's no longer operating, your server is as well, the data is still in place, but you cannot access it. But then your application and clients is still going fine. How can this be achieved? So basically, there's not a lot of magic in here. These are concepts that are well understood over time. You have instances in both or two or more availability zones. Again, these are very distinct. And they have nothing in common when it comes to network or power. And you can basically survive fully by using a load balancer in front of these availability zones. And the client will never know because they enter for the load balancer and the load balancer does health checks. And if it detects that an EC2 machine is not working, it stops sending requests. Now, this is all fine for HTTP requests and for your application code. But what about the database? Well, the database is a bit more complex than that, but luckily for us, it doesn't really matter. RDS has a concept that is called multi-AZ, which in the background sets up a replica database server. It's basically in standby mode. And there's a DNS endpoint in which your application connects. In the event that something happens to the RDS master database, like an availability zone going down, it automatically detects and changes to the slave environment, to the slave database server. You might ask, what happens when the initial master comes back online? Well, that is pretty easy. It just becomes the new slave. And now, while I have been talking, I forgot that this part takes a bit, and I should be cloning the environment. So let's add a new production environment. I'm going to do something like this. Clone environment. Production. That seems pretty decent. All right. Now let's go back to the slides. So, as I said, a lot of magic happens in the background for RDS. There's actually a lot of automation in place for you, and all you have to do is click that multi-AZ button. What this means in terms of costs? Well, there's no way to go around this. Basically, you're going to have to pay for multiple instances. So whatever instance you had in one availability zone, if you want high availability, you have to pay for 2 instances because they have to be running at the same time in different availability zones. Same holds true for RDS, right? You only click a button, but in the background, they spin up a new database server. They configure it to automatically replicate any data or new changes coming from your master. And they have a nice little DNS health check and endpoint that they close to instantly switch if something happens. Usually, your clients never notice. All right, so keep in mind this architecture on the right. What we're going to do is clone our test environment. Obviously, we wouldn't want to do it again manually, not just because this is faster, but because it lowers the chances of human error, right? I might be forgetful and not put a parameter that I would be already having in test. And then our application in production would be using different settings or different configuration. This is something that is usually fixed by implementing infrastructure as code, something that we're going to be talking about in a future webinar. After we clone our test environment, we're going to want to make it highly available. So very easily, we'll be able to add a load balancer, a second application server, and a replica for our main database with automatic failover. We're not going to stop there. Since this is so easy, we're going to configure auto-scaling. And by auto-scaling, I mean, and this is not yet done. By auto-scaling, as a concept, what does this mean? Let's say you have an application that has variable load. This is mostly everybody, but the best example I can find is a food ordering website. Obviously, you're going to have your peak times at noon and maybe in the evening. Between those, especially until morning, you're going to have little to no traffic. Now, let's say you have to provision 10 servers to handle the traffic that you receive at lunchtime. Obviously, people are at the office, they can cook, and they're very hungry, so you're going to have a lot of visitors. But is it not like a good idea to pay for 10 servers 24/7 when you only need it for like 5 hours a day? What if you could only pay for 2 servers for the rest of the time? That would end up with some really, really considerable savings. All right. How can you do this? So first, you have to think of the right application metric for you. Some applications consume a lot of memory. Some applications consume a lot of CPU power. Mostly it's the second one. We're going to be using some very good defaults, but usually that's where we start, defining the metric. So when do we need another application server? Let's say when we reach 80% CPU. All right. When should we remove a database server? When our load is less than 20%. So by implementing this rule, we don't even have to think about when our next big load will be on our service. We don't care. We base our decisions based on metrics, and it's all automated. That's auto-scaling in a nutshell. And of course, this is not yet complete because it's also creating a new database. So this might take another minute. All right, then we seem to have a Q&A session. I hope I'm pronouncing your name, Antropov, correctly. The question is using AWS historically a necessity, customer desire, or coming from an expert? Have you made the financial analysis of using AWS, Azure, or Google Cloud for similar projects? So usually it comes from 2 places. The top-down approach is when you have the client that actually wants to use AWS because, let's say, he is in a startup circle. He himself is a startup. Everybody's using AWS or a cloud service that is relatively similar, and they're very happy with the outcomes. So obviously, they want to have the best tools for the job to give their business the most chances of success. As in our scenario today, we're trying to fulfill a relatively difficult task very quickly to get a production or at least a test environment up and running to showcase our stakeholders tomorrow in our sprint demo. But I would also say it is a necessity because as we said, it abstracts very much of the complexity required to run a successful application in production. We don't have to manage the backups. We don't have to manage the load balancer. It's a commodity. It's like installing a package in NPM or with Maven. Basically, if it's something that works really well, it's reasonably priced. Why should we spend time on this when our competition isn't, right? They're focusing on the features that they have to deliver for the end users. And if we were not to do this without a very good reason, we would basically lagging behind constantly and having downtimes and having to invest a lot more money. So that's the top-down approach. When it comes to the bottom-up approach, basically development teams, usually when they try, however reluctantly they try cloud services, they find themselves keep coming back for them, right? Because it's easy. And whatever is easy and does the job is popular, really. It's not perfect, nothing is. I like to say that the cloud is less horrible than the other options. All right, before we take another question, let's see if our application is complete. Not yet. The quick reload in here. Another question from Tudor. How do you choose the resources necessary for a certain Java app? Start small and then increase as needed. You're absolutely correct. So obviously, you know the specifications of your own laptop, right? For example, mine's an i5 Intel with 16 gigabytes of memory, and I can see how much it's running initially. But that doesn't always translate to what happens in a cloud environment, because they have their own terminology. Each cloud provider does. So for example, for AWS, there's a really nice website called ec2instances.info, and it's right now on the screen. And what it allows you to do is basically compare very easily all of the specifications and the pricing that you would have for, let's say, an EC2 instance. But it also works for databases, right? So in our case, let's say we want something that's cheap, and we're looking at Linux on-demand cost. Right? We can see that we would have, in Paris, we would have to pay $4, close to $4, for a T3A Nano instance that has half a gigabyte of RAM and 2 virtual CPUs. Now, keep in mind, whenever you see these burst data here, it means that you can't use your CPU 100% of the time. I mean, you can, it will just cost you extra. So for very low demands, for example, as a test environment, you would use something like a T instance. T instance are the burstable types, and they have like a credit system. You start with a number of credits, then you accumulate credits as the hours pass. And when you do a lot of load, like when your CPU goes above a certain percentage, it starts draining those credits. Basically, it's Amazon's way of sharing the CPU power at a lower cost. But by default, if you're using T3 instances, you have something called unlimited T something unlimited mode, which means that it will not block or the CPU. It won't crash your applications when the CPU credits run out. You'll just pay extra for that half an hour that you are doing so. So if you want something like burstable instances, go with T type instances. If you want something for constant load, large constant load, go with any of the M, which basically means all around type of instance, or C, which means high compute. There's a lot of information when it comes to the types of virtual machines that Amazon or any cloud provider has. They usually go around in families. So the T's are the burstables, the C is high CPU, the R's are the memories, the G's, and I forgot something else, are the graphics enabled. So basically, if you're using for applications such as deep learning, machine learning, AI models, basically anything that will require real graphics card. All right. So that's how I usually figure out what I need to use in the infrastructures and architectures we deploy for our clients. We take a look at what's usually happening on a dev machine, and we extrapolate from there. And again, if at any time you feel the need to, if production isn't ready here, I'm just quickly gonna go to what it is. So let's go to the configuration. Let's say I figured out by monitoring our nice little graphics here, which are just starting up because we just created production. Actually, let's go to the test server, test environment, sorry. If we were to look over here, and let's say our application was constantly at 80, 100% CPU, we would just quickly go into the configuration. We'd go into the instances, and we would go for a T2 micro, which is, let's see, a T2 micro, which we have over here, is 1 gigabyte of RAM and 1 virtual CPU, which is almost $10 a month. We would go to something else, let's say, maybe a bigger T instance, maybe a T3 2x large or something, just to try it out. And you can basically change this fairly quickly, but I wouldn't do. This is very easy when you have like a highly available environment, because this doesn't really break your application. Doing this with a single server, it will obviously cause some downtime. So, hope that answers your question. If not, add another one with specifics, and we'll take care of it at the end of the session. All right, let's look at our production environment. Does it work? Does it work? Does it work? Yes, it does. But just because I'm paranoid, I'm gonna add yes, it does. All right, so looking at the slides, we have cloned our test environment. It's just like the test environment. So let's add high availability to it. I'm gonna go into the configuration, and this is gonna be really easy. I'm gonna go into the capacity. I'm gonna change it from a single instance to a load balanced. Just for the sake of it, I'm gonna put minimum 2 instances, maximum 5. Leave any availability zone. So we have 3 availability zones in the current region, which is London. So we're gonna let them all here. Scaling cooldown means once the scaling action has happened, all actions are stopped for basically 5-6 minutes, however you want to put it here. This is a good practice, right? Because if you have a big rush of traffic, you don't want to start 10 instances all at the same time. Let's start one by CPU. Let's set up auto scaling by CPU. So we would do CPU utilization. We would do average. Let's select % in here. And we would say, let's say anything over 80% for more than 2 minutes adds another EC2 instance. Anything lower than 20% for 2 minutes, remove an EC2 instance. Mind you, they will never go below 2 instances or above 5 instances. So this is basically your safety line. You will not pass the 5 instances, so you can always calculate the maximum cost for an environment. All right, so I've configured high availability and auto scaling. I'm going to quickly apply. All right, and this is basically handling this part, right? It's adding the load balancer. It's adding the EC2 machine in a second availability zone. Now let's go ahead and actually do the same for RDS, for the database server. All right, we're going to go to the database. We're going to modify it. And we're going to go from a low availability to a multi-availability, a multi-AZ environment. All right. That's interesting. I should wait until the environment is up to date. All right, let's take another question. How do you choose the resources necessary for Java? This was answered. Pierre, would you also recommend using CloudFormation for deployment automation? What would be the advantages, disadvantages versus Beanstalk? In which use cases would you use one or another? Right, so this is touching on the infrastructure as code. Infrastructure as code is an awesome concept. It basically allows you to store your infrastructure in your Git repository as any other application. And you can treat it the same way. You can review it, you can deploy it, you can revert back to a necessary state. However, when it comes to options, it's not as simple to basically respond to that. We usually recommend staying inside AWS stack, so AWS ecosystems. which basically means for general uses, you would use CloudFormation. Historically, you would be using CloudFormation, which is basically YAML templates. It's not the best developer experience, but what's nice about it is that they do manage. CloudFormation is also the templating language and also a service, and you supply the desired state, and they build the whole infrastructure for you, and they manage the state accordingly. So you don't have to do anything else; just provide those templates. When would I use Elastic Beanstalk? So Elastic Beanstalk is very useful if you do not have a lot of knowledge yet in the cloud department, don't have a lot of DevOps knowledge. If you want to do something quick for a proof of concept, or you're just starting out. As again, we've specified our context for today is that you're on a greenfield project, you started development, you were promised some resources. Of course, this will never happen to you, but theoretically speaking, you haven't gotten those resources, and you have to provide the leadership for your team, or if you're a single developer working on an experiment or a proof of concept for a new service inside your company, you'll have to do whatever it is you can do to deliver something in the time allowed. So if it's a proof of concept, if you don't have a lot of AWS knowledge, because this really handles a lot of, abstracts a lot. So if you think about cloud services abstracting all of the hardware and the usual components, the commodities of running an application, Elastic Beanstalk and CloudFormation are a step above that. It's just that you don't have to have a lot of knowledge to work with Elastic Beanstalk. As I've chosen today, I'm choosing to do it inside the graphical user interface, the actual console. Now, I'm going to say something else. When it comes to infrastructure as code, there's a new kit on the block coming from AWS, which is called Cloud Development Kit, which allows you to use a real programming language to create your infrastructure. I'm not going to go into a lot of details. It will be covered in a future webinar. This is the first of many on the AWS topic. But I would like to say this. What it does is it generates CloudFormation for you. So think of it, think of it as Python or TypeScript code describing your infrastructure, creating your infrastructure actually. You can use a real programming language, and in the end, it gets compiled down to CloudFormation and deployed for you. A really interesting experience. All right. We have our new highly available production environment. Let me close these. And let's go. There we go. Awesome. It works. Before we go further, let us also configure that database. Yes, I just added a replica with automatic failover. Well, that was easy. Okay. So while that's happening, we have configured autoscaling. We have added more than one application server. And to showcase that it actually creates and manages all these servers for you, I'm going to go to the EC2 servers. And we're actually going to see how many instances we have right now. All right. This is our test environment. Sorry, I didn't name it properly. And this is our production environment. We have 2 instances, and we have a load balancer over here that's forwarding our requests over there. Awesome. All right. The database is updating. Okay, so while that is updating, let's move on to the next part, the very interesting part, setting up continuous integration and continuous delivery. Now, I'm saying continuous delivery and not continuous deployment. I've mixed them up for God knows how long. So I built a short graphic to showcase what everything really means, and in a very easy to understand way. So continuous integration is when we commit, we have a bunch of stuff running on our code. It's tests, linters, unit tests, whatever you fancy, basically. But it's a way to continuously check the quality of our code and integrate it at the same time with other people's code in a shared branch. Now, going above that concept, continuous delivery is when we automatically deploy our feature branch or whatever type of branch you want into a test environment, where it is, of course, subject to a human review. This can be one or more testers, QA engineers, and basically somebody has to approve it, and it automatically goes to production. So everything here is automated, but this human action of verifying and approving the change a developer has done. Continuous deployment is actually the next evolution, is when the developer pushes the code, it automatically gets checked by unit tests, it automatically gets lint checkers. It goes to a test environment where, this is very important, a group of high quality automation acceptance testing, or maybe not just acceptance, also functional, thoroughly checks out the quality, that there hasn't been any regression, and automatically deploys it to production. There is no human interaction whatsoever. So that means that you have to have a group. Basically, your automation has to be automation or acceptance testing has to be in a state where you trust it a lot. You have to have a high degree of confidence in the tests you have there, and then the fact that the tests cover all the major features or operations that your client would be using. So if you have that degree of confidence, you can automate the part and basically have the lowest amount of friction going from dev to production. So how can we achieve this in a cloud environment like AWS? So first, I know that some of you, if not all of you, are going to have some experience with some CI tool already, either GitLab or Jenkins or everything. This is going to be slightly different. And I'm going to talk about a bunch of services, and I'm going to explain some of the qualities or features that they have, trying to do this, of course, in a short amount of time. So code pipeline is like a Jenkins. It basically defines all the little pieces that have to go together to deliver this continuous delivery flow. We start by using a service called Code Commit, which is basically a hosted Git service from AWS, which then flows or pushes the code onto Code Build. Code Build is just like your worker node or agent in Jenkins that basically runs all the commands you give them to. Again, you could use JUnit or whatever other type of unit testing framework or linters you want to use. You have a Docker container that is automatically provided. You can also supply your own. This is very, very good feature, especially if you have some custom requirements and if it would take you too long to install your necessary dependencies in there. When it comes to test, you should also use Code Build because basically it runs your container. You can also use Code Build with other tools. You can start other tools. You can start your automation from Code Build. You can do a bunch of things. Basically, you have a Docker container at your disposal. You use it however you wish. When it comes to deployment, you have an AWS service called Code Deploy, which handles a lot of strategies. It can deploy on-premise by installing an agent. It can deploy inside AWS for EC2 machines, Docker containers, serverless functions, you name it. So it's extremely powerful. Let's see if we have that database. Not yet, it seems. Okay. Right. So what actually are we going to do right now? We're not going to be doing continuous deployment because obviously we don't have a high quality set of automation test scenarios already built. We do have the necessary components for continuous delivery. So we're going to start by creating a code commit repo, adding a code build project. how that fits in, and what we have to do in our application to facilitate that. We're going to create a code pipeline, and we're going to push that. So let's start by creating a GitHub repo. Not a GitHub, a Git repo, sorry. We're going to go into code commit. We're going to choose a descriptive name for our repository. Obviously. And there's two ways of connecting to it. You can use HTTP authentication or SSH keys. And the way you allow developers, people to connect here, is that you have to have an IAM user. IAM stands for Identity and Access Management. It's basically the users to your AWS account. I have already added a user called Webinar, and I've give it access to code commit. There are permission levels, templates you can attach directly, so you don't have to worry. So if you just search for code commit, you have read-only power user and full access. I gave it full access. And then you have to generate in the security credentials tab, you have to generate your HTTPS quick credentials or upload your SSH keys. I chose to create HTTPS set of credentials. Okay, I already configured my IDE, so I'm not gonna bore you with that. But let's first push the code. So I'm gonna configure the remotes. I'm gonna add an origin in here. Awesome. Let's see, we have a new file in here that we added when we created the test environment. Added elastic beanstalk configuration. All right, commit and push. Pushing now. All right, so we have our code in here. Obviously, you have some pull requests, anything you want, but you don't have to use this Git repository as your main application repository. I sometimes explain it to dev teams this way. Think of it as your entry point into the pipeline. So if you have Bitbucket, GitHub, you can configure them automatically to push in here, and that basically takes care of everything for you. And the best part of all these services, especially code build, as opposed to GitLab or any type of CI/CD tool, maybe like Jenkins, that you would have to run a server with 24/7, is that here you don't pay for 24/7. You pay for however minutes you use code build, for example. You don't pay anything for the code pipeline itself. You do pay, well, that was the last time I checked, so we might have to check that. Let's check that quickly. I would want to say something. Oh, one pipeline for each month. All right. Sorry about that. Then it's $1 per active pipeline. $1 per active pipeline. Okay. For code build, you are billed by the minutes you use them. So if your build takes a minute, you are billed with a minute. You don't pay 24/7. All right. So we have our repo in place. Let's create a code pipeline and a code build project. Code pipeline. I'm going to create the pipeline. I'm going to call it, of course, webinar. What else? I'm going to go with next. We're going to select code commit. ECR stands for Elastic. Basically, it's the container registry. You store Docker containers there privately. You can also use S3, which stands for Simple Storage Service, a place to put your files, object storage, and GitHub. But let's go with code commit. But webinar, our branch name is master. We're going to go with code build as a build provider. You can also use Jenkins in here. I like code build because I don't have to pay for it 24/7. Let's create a new project because, of course, we don't have anything set up. Let's call it again webinar. Managed image. We're going to go with Ubuntu on this one. Standard, the latest one. Build spec. Build spec is actually the instructions on how to build the artifact. So basically the program that you want to deploy, your application. And you can do this by inserting the build commands in this UI, or you can use a build spec in your GitHub repo, which is quite frankly much better option because it allows you to edit things in one place. If you were to change something in your application that requires another command to compile the TypeScript into JavaScript, for example, or to do other things, it's much better to handle everything in a single repo and a single commit. So that's awesome. All right, the code build project is created. While we do that, let's add the build spec file. So the build spec file is exactly as you might think it is. It is some YAML that specifies that we're going to be running Java 8. It installs Maven, and this is basically something that you can use to install whatever you would like. However, if you have a lot of stuff to install, consider creating your own custom your own custom Docker container, because that would decrease the running time, so it will make the pipeline run faster and would allow you to pay less. All right, and it does Maven install. It then prepares our zip basically for us. It moves the jar file that was created to a file called application jar. And just after that, we specify that we want to have EB extensions environment config. And this is a file that you can use to configure a lot of stuff by default in Elastic Beanstalk. It's all in the documentation. It's quite extensive, I must warn you. And the application build file. Code build automatically compresses this into an archive and sends it forward. All right, let's actually do that. Let's add another commit with our build spec. Add code build configuration. Commit and push. Alrighty. Let's get back to our pipeline. So we have a new code build project, and we're going to deploy it straight to Elastic Beanstalk. Let's call this, let's use the application name webinar that we configured in Elastic Beanstalk. And we're going to go to our testing environment first. And we're going to create the pipeline just with our test environment at first. The first time you create the pipeline, it automatically takes whatever you have in the branch that you configured, and it starts the pipeline for you. And we're going to be seeing that in just a second. Well, then let's create. There we go. So this has started. Oh, sorry, I'm just checking the presentation. All right, so first step of the pipeline is complete. Code commit has sent the sources to our build step, and we can see very easily that our basically our commit ID is here, and also our message. And let's take a closer look at what happens in code build. Give me the, all right. So right now, Maven is installing the dependencies. It has completed the build. It has succeeded. It took 1 minute. That's not a lot. And let's go back to our pipeline and see how things are going. Right, it is currently deploying on our test environment. Let's wait for it to finish, and then we can add our manual approval and our production environment. While that is happening, let's go for another question. Jean is saying, is this webinar being recorded? If that's the case, is it possible to get the video afterwards? Yes, this is recorded, and yes, you will be sent the video and the presentation afterwards. Antropov is asking, how rapidly, how rapidly will autoscaling increase the count of instances? For instance, for example, instances was working normally with 100 regular connections. During 2 minutes, their count have increased by tenfold till 2,000 connections. Will application work correctly during those 2 minutes while connections are increasing like avalanche, right? So for your use case, if there's two types, there's two answers here. So one, you have to have an efficient process, efficient configuration for autoscaling in mind. If you have, for example, the expectation of receiving avalanches of traffic in a short amount of time, but you don't know the time, you should strive to make the installation of the boot up of EC2 machines with your application very quick. So in this case, Elastic Beanstalk is handling everything for you. And a more custom scenario, you would be installing all dependencies on a virtual machine image called an AMI, which will start automatically with all the necessary dependencies, just requiring your application code. This is automatically handled for you in Elastic Beanstalk right now, because there's only a set amount of languages and versions. But that's in a custom scenario. Also, you should be taking a close look at your metrics. So for example, if you have a connection count of 2,000 and your application is buckling, you should definitely set up your metric, for example, to 1,000, right? So when you see that load coming in, auto scale immediately, and don't auto scale with just one instance. If you know there's a surge in traffic, you can set up auto scaling to start adding, let's say, 4 or 5 instances, initially when you get an upscale event. The other side is, if you know when your traffic surges will come, for example, your clients are running a very high profile marketing campaign by doing TV ads, such as the Super Bowl, you can set up automatic scaling up actions to happen at regular times. So for example, before the ad runs, before, let's say, half an hour or an hour, you would like to add 100 instances, and then let autoscaling manage decreasing and increasing afterwards. Hopefully that answered your questions. All right. So we have deployed automatically on our test environment. You just quickly go over there and make sure everything is working as we expected. All right, application is still here. Let's go and add our production into place. So let's edit the pipeline. Let's add another stage. Let's say deploy. Actually, let's do it here. Edit stage. Add an action group. Manual approval. And we're going to select manual approval. You can see you have a large amount of options here, from Jenkins, code build, a bunch of other AWS services, containers, and all that. Lambda, which is the serverless function as a service. Service functions. We're going to just go with manual approval, not have to do anything else. Remove our space in there. So we got our manual approval. Let's go with production. And we're going to add, of course, another Elastic Beanstalk action. We're going to use the build artifact. We're going to go to webinar and production. Click done. So these are the stages and action groups. And you can see they all flow basically towards the towards the end of the pipeline. We're going to save. And right now, we have a nice deployment flow set up with manual approval after test and and then it goes into production. So this is the last part of the demo when we make a change in our local environment and push it all the way through to production. Let's go. What should we do? Let's change some text, right? Should we go with H1? Welcome to the Java webinar. Thanks for joining. Right. Let's validate that this works locally. Let me just rebuild it. Also push the code right now. Added message. Hey, there we go. Thanks for joining. It is now pushed. Now let's do another change so I can show you another feature or how the pipeline works. Let me remove the message. Remove that message. We're going to push it. So right now, it is building it. The commit for added message is going through the pipeline. So let's just say these two are, of course, separate features. We added and then we remove the message. And it's going through the pipeline. Let's say we want to stop the pipeline for a second, for whatever reason, just so we can look at the test environment without any other interaction. We can disable the transition between the build and the deploy phase very quickly with just one button. Let's take a small look into our test environment. Do we have a nice new welcome message? Yes, we do. Let's say the QA engineer approves. You can also reject, by the way. You have approved the feature and you would like it to go to production. This automatically happens. You don't have to do anything. And the deployment to production is happening as we speak. While we do that, let's also enable the transition again. When you enable it, it will show you the reason that you added and also when you disabled it. So 1 minute ago, enabled it. And we'll be able to, of course, review anything before it goes to production. I changed it a bit too soon. Yes, when you re-enable it, the transition, it stops the next deployment. Sorry. Oh well, I guess we'll have to add another message. Another message. The good part of continuous integration and delivery is that it takes very little effort to deploy something. That's the good part of the automation. All right. Commit and push. Let's just say I didn't want to deploy the previous commit, so I'm just going to reject it and let our newest let our newest added message run through the pipeline. Okay, let's take another question. Is there any rollback procedure integrated into pipeline? For example, if the deploy staging was normal, all tests were passed, but the deploy to production breaks and application is broken. Will we need to start another deploy pipeline with previously successfully revision, or can we just push a magic button and the application will be rolled back? So first of all, if the application fails to deploy, everything would automatically roll back. It won't stay broken. If, for example, you have something that succeeds to be deployed, but then you have an issue that it errors out, the auto-scaling would detect this issue and it will try to replace those faulty instances. It will try to boot up another instance and install the application code there. In this instance, if that doesn't work, you will have to do basically what is called a fix forward procedure. You just push the right commit that you want into that branch, right? So if you want to move it back by one commit, you just do a git push force into the code commit repo with any version that you'd like, and it will go through the pipeline. So in a way, it has some safety mechanisms. It will stop a deploy if it doesn't install properly on the server. If any of those commands fail, you'll actually get the message in here why that failed. But if it doesn't, and reinstalling the application built on a new server doesn't work, you'll have to roll back by pushing an older version, which you can also automate, right? You can do something, but it's not included by default. All right, we're gonna check again. We have another message, of course, and now we're gonna approve it for production. I know we've been answering questions throughout this session. We're coming to a close soon, so please add whatever questions you might have now into the Q&A section for this Zoom webinar. All right. Let's take a look at the production environment since we're here. See how those all right, the deployment. Yay. Awesome. So it has succeeded. Let's take a look at production. We have another message. So there you have it, from the editor on our local machine to a test environment, and with manual approval to production. That concludes our demo for today, where we changed that app. We added a new change. We committed. We saw the change in test. We approved it. And in production, now we're happy. We have continuous delivery, and it took us very little time. I'm sure our stakeholders tomorrow will be happy when we demo our proof of concept. This cycle of continuous integration and deployment really is two of the three pillars of releasing modern applications. The third one we touched upon is infrastructure as code, because basically now everything is in your Git repository. It's tracked. You can use best practices for infrastructure as you would use for any other software product. And it's actually as it should be. It's our full application, start to finish, and in our control, always available to review and deploy to our wish. Because, and I like to explain to clients, when we do it in infrastructure as code, it might take a while at first, but when you want a new environment or a new application deployment in another region, for example, Australia or England or America, well, it takes us very little time and there is no human error. Everything is automated. So that's very nice. Now to the Q&A section, I see we do have one question left. Edward, any thoughts on handling database migrations when deploying a new version with application version with a pipeline? So that's a very interesting question and a very difficult one to respond to. Usually every major framework out there is handling database migrations with whatever they're calling these days, upgrade scripts, data fixtures, whatever you want to call it. Basically, it allows you to specify seed data that you want to be installed, or new structural changes to the tables that you want to be installed when your application is deployed. I would say two things to that. First, you could let it happen automatically with the functions from the framework itself, whatever you're using, or you can do it yourself, not yourself, like programmatically do it by adding another step in the pipeline, which runs a specified command. For Elastic Beans, this is mainly applicable to containers. For our scenario today, we would add another file that is in our GitHub repo that specify what commands should be ran at install time. That is a separate file, not a build spec file, because that happens way before the deployment. To answer the main question here, how do you handle database migrations? Well, it's a fix forward type of thing. Usually people like to use feature switches or to have a policy to only append, never to rename or delete database fields. And what that allows them to do is basically roll back application code if something goes wrong, and the application code defines all the necessary tables. But this can be quite cumbersome after a while. And then what you have to do is actually, when you want to redesign the system, you have to generate a new table and manage this this technical debt, so to speak, quite rapidly, because you're writing into two tables and you want a single source of truth as fast as possible. So after a short amount of period that you test in production, you would remove the old code and table after everything is in the new table in the format that you now wish. But generally, append only tables. When you refactor the code massively, you also do the same for the data part. And don't forget about the strategy when it comes to upgrading the actual structure in the database, because sometimes if you have a highly available environment and you have two application servers trying to write to the same database schema, like to create the same table, one might fail and might not be the best experience for your users, right? So that is sometimes better automated as a separate process after application installation. All right. Does AWS Code Deploy have partitional continuous deployment feature? I'm not sure what you mean by that. You give an example here. You have a cluster with 5 instances. After deployment to production, it pushes code to 1 to instances. All right, and load balance 10-20% of the traffic on them. So basically, you're talking about a canary type deployment. What I will say is that Canary is supported for functions as a service, so serverless functions by default. It's quite nice. When it comes to deployment strategies, you do have a few. It would be best if I show you the necessary documentation page. Code deploy strategies. AWS code deploy strategies. So this is the deployment configurations. Let's see. So by default, all at once, in place, it attempts to deploy to all instances. Second option is half at a time, in place, basically. Overall, one at a time. So this is the in place. It's kind of like the canary, but it's just one by one. So that would be the ones for EC2 instances. The ones for Canary, which are supported by default, is unfortunately only for Lambda. So you actually route 10% of the traffic to the new function over 5 minutes or 10 minutes or stuff like that. Have a look through this page, and I hope this actually clears the situation for you. I'm going to reply. All right. So, if there are no other questions, I'm going to take a small look at the chat as well. Right, there's a question. Oh, I'm going to scroll back a bit. Good, good. The webinar is recorded. There's a question from Facebook Live. Is it possible to use CloudFormation with Beanstalk? Yes, it is. So CloudFormation does have resources for Beanstalk. However, Usually it's like a transition period, because if you use Beanstalk, usually you need, CloudFormation, you do have some more custom needs. I do also always like to promote infrastructure as code. So yes, definitely you do have support for CloudFormation. If you'd like to use a real programming language, please check out CVK. So that is Cloud Development Kit by Amazon. The most supported language, let's say, with examples, is TypeScript. Yes, so those are every question on the chat. Let's also look at the QA. That is it. If you do have other questions, please email me. My email address is on the last slide of this presentation. So that would be this one. Please email me. I'll try to respond in a timely fashion. Oh, one more chat. Okay, thank you too. Thank you very much for joining tonight on our first of many webinar dealing with AWS. This evening we talked about how to quickly deploy your Java application in the cloud with AWS. Stay tuned for the next subjects, which will handle more programming language and scenarios. Thank you very much for joining in, and I wish you a wonderful evening. See you in the next one.